Good afternoon, everyone. My name is Robyn Scott, and today I'm going to be talking about fire and regeneration in wet forests, an evolving story. So I'll be talking a bit about how our understanding of fire and its use in wet forests has been changing over time, and how our forest practices have been as well. So this is just an outline of the points that I'm going to cover in today's talk. I'll be talking about fire and wet eucalypt forests and how those two things are important. I'll also be talking about variable retention and aggregated retention, a new form of harvesting that we've been using in our wet eucalypt forests, and how that's posing some burning challenges when it comes time to regenerate those forests. I'll talk a bit about a monitoring program that we have in place and how we've been going in terms of adaptive management in these kinds of coops, and at the end I'll sort of try and come back to a summary and come up with a few key points to finish off. So wet eucalypt forests include some of Tasmania's most iconic and also most valuable forests and some of its tallest trees. So things like the Styx Valley and the Florentine Valley are wet eucalypt forests. As the name suggests, wet eucalypt forests are wet, and they're often quite productive because of that. So they have trees up to 80 meters tall and above. And they contain eucalypts, so they have eucalypts over a dense understory that often consists of rainforest species and sometimes broadleaf sclerophyll species. Eucalypt forests are naturally dependent on fire, so they regenerate through fire. If we have a eucalypt species, those depend on having a mineral earth seedbed and can't grow under a shady canopy. So in order to regenerate, these coops need to have some kind of major disturbance to create that seedbed so that they can then grow up again. So the likelihood in any kind of wet eucalypt forest is that fire must have been there at some point for those trees to be present, and the likelihood is that fire will come through again and disturb that stand. Fire is naturally present in wet eucalypt stands. It's also something that we use as part of our silviculture or our forest management. So when you see a wet eucalypt forest, when we harvest those stands, they have the dense understory, and that creates a lot of slash, and also shades the seedbed. So in order to regenerate these forests, we need to create a big disturbance like a wildfire. So we often use fire for this. So wet eucalypt forest silviculture involves what we call clearfell, burn, and sow, in which we remove all the trees from an area, clearfell it, and then we would do a high-intensity burn and aerially sow eucalypt seed over the same area. So this picture, you can see, there's been a really hot burn on this slide, and it's created some really good burnt seedbed for regenerating some eucalypts on. And generally, this kind of silviculture is successful. It creates a nice, young, vigorous regrowth stand of eucalypts that then tends to grow quite quickly because of the burnt seedbed, and we get a new forest coming up right away. But there are some issues with this kind of silviculture, in that clearfell, burn, and sow silviculture isn't highly socially acceptable, and it's becoming less socially acceptable as time goes on in our native forests. And also there are some important differences between clearfell, burn, and sow and naturally disturbed forests. So we know that natural wildfire disturbance is a little more patchy than clearfell, burn, and sow than our forest harvesting is. So we get much patchier disturbance on the landscape, and we also get some areas that have been quite disturbed and other areas that the fire will miss. So we get what we call fire skips. And you can see in the picture here some of the burnt areas and then some green areas where the fire skipped over, and that those are in different sizes on the landscape. Another difference between wildfire and fire that we use in our management is the fact that we have biological legacies. So if we do clearfell, burn, and sow across quite a large area and repeat that over time, we're basically removing all the trees from those harvested areas, and over time we'll lose all of some of the structures that would be there if it had been naturally disturbed. So in a stand like this one, this is a mature wet eucalypt forest. If fire goes through that, we would expect there to be some live trees and some dead trees, and some standing trees and some coarse woody debris left behind. So those biological legacies are actually quite important for biodiversity. And so our growing understanding of this has led to the use of new harvesting methods. What we call variable retention harvesting is something that's been developed in the past several years for Tasmania, and the idea is to better emulate some of those natural disturbance patterns on the landscape by leaving patches of trees behind. And This is sometimes called green tree retention or structural retention, or you might hear it called variable retention. Basically, there's a lot of different forestry practices now that use this retention approach, and it's becoming basically the gold standard for native forest management around the world. So you can see here different examples where retention forestry is being used around the world. It's being used in both coniferous forests and broadleaf forests, and in temperate and tropical areas, although it's probably still more common in the temperate areas. But the point is that it's a very flexible approach, and so we can use that in almost any kind of forest type. It can be adapted, but we have to use different patterns and different methods of harvesting depending on the forest type. So in some of these you can see aggregates where they've retained patches, and in other cases they've done dispersed trees as single trees. And so the objectives of variable retention harvesting are really that retention of biological and structural legacies that we talked about that are important from the previous stand, that we want to keep those in the new and regenerating stand. We also want to help old growth species reestablish in the harvested areas and maintain some landscape connectivity. So those are the three main objectives of variable retention harvesting. We're lucky in Tasmania in that we have a long-term research site that's been set up at the Wara trial, where we've tested some of these silvicultural systems. And we started this in the 1990s to test for alternatives to clear felling in wet eucalypt forests. And we've got several different alternatives here. We've got clear fell burn and sow, or CBS. They've got examples of strip fells, patch fells. They've done something called group selection, where they take out small patches of trees. And they've also tried two forms of variable retention. That's aggregated retention and dispersed retention. And essentially, they then monitored all sorts of things at Wara, and we're trying to come up with the best alternative to clear felling to use in tall wet eucalypt forests. And the outcomes from Wara essentially said that aggregated retention was the most promising of those alternatives from a regeneration perspective and from a broader biodiversity perspective. So it helped to maintain some of those biodiversity benefits that we were looking to maintain. And that it also seemed to get fairly good regeneration. But as you can see here, Mark Neelan did his thesis at Wara and found that burning the aggregated retention coops to provide a seed bed for regeneration was really the biggest challenge. So following on from the trials at the Wara silvicultural system, we moved to operational implementation of aggregated retention, and this was based on the commitment by the Australian government under the TCFA, the Tasmanian Community Forestry Agreement, in 2005. The Australian government committed to reduce clear felling in old growth forests to less than 20% of the old growth harvest annually, and so we brought in aggregated retention as our alternative to clear felling, based on those results from Wara, which said that it was the best and safest alternative to use. So starting in about 2004, we brought in operational harvesting using aggregated retention, and since then we've harvested about 70 variable retention coops across Tasmania. But as I mentioned, burning these for regen was sort of the biggest challenge. And this is a picture of a conventional high-intensity regeneration burn, and you can see that these ones, we generally would light them with a helicopter. We use aerial ignition. The helicopter drops burning fuel out of it to light the fuels on the coop. They go around, light the center first and then the edges, and this creates a really good central column and a really hot burn and some good seed bed. But in our aggregated retention coops, we can't do that because we've actually left these aggregates or patches of trees behind, and we don't want to burn them. So we had to find a new way of burning our aggregated retention coops. And what we've come up with is what we call slow burning. And we got in some expert help to help us develop this type of burning. And what Dick Trudeau came up with was a prescription that involved a creeping fire, not a convection burn, something where we're going to light it later in the day when relative humidity levels are rising. And it depends on having dry fuels and wet forest edges to try and keep that fire out of the surrounding forest. So there's a fairly short window for this kind of burning. And there's also some negatives in that it can cause greater smoke management issues. But in general, it seems to have worked and allowed us given us an opportunity to actually burn some of these aggregated retention coops. And so based on this, we've been doing some monitoring and research. We've been monitoring all of the aggregated retention coops that we've been harvesting, and we've also looked at a set of paired clearfell, burn, and sow coops so that we can compare the two systems. And that's just a map showing all the different locations of the coops that we've been looking at over the past 4 years or so. And some of the things that we were interested in tracking were things like fire breaks and what kind of impact those were having on the coops. We were interested in how much area we might have been burning around the coops. We were also interested in the seed bed that the burns were creating and whether that was leading to good regeneration. So I'm just going to talk a bit about all of those results. So one of the first things was fire breaks, and we were a bit concerned about this because we knew that aggregated retention coops had higher perimeter area ratios, so we're increasing the amount of edge, and we're putting fire breaks around those coops, which might cause negative impacts on the soil. And when we looked at the first set of coops, we certainly found that fire break cover was much higher in the aggregated retention coops, about 15% higher in 2007. So this was a bit of a worry because we know that fire breaks don't grow very good trees. So we quickly made some changes to our fire breaking practices. We tried to reduce our fire break widths and only put them where they're actually necessary. And we also changed the way we put fire breaks around some of those island aggregates and changed to what we call raked fire breaks, where we try to avoid disturbing the soil, but we just remove the fine fuels. And those changes actually did show then in our monitoring as well. So here we have that 15% difference between aggregated retention and clearfell, burn, and sow to begin with. Here we have something showing the difference between aggregated retention, that's ARN, and clearfell, burn, and sow, that's the CBS. We've got fire break cover on the x-axis and year on the y-axis. So it's showing again that 15% difference in 2007, and then that difference was decreasing over time. So our changes to fire breaking actually did make a difference to the fire break cover across the coop. Something else that we were also interested in was the impact of the burning on the area surrounding the coop. So it's not unusual when we're doing these high-intensity regeneration burns to have a bit of what we call slop over or overachievement. We tend to burn a little bit of area around the coops. But with using these aggregated retention coops, we were concerned that we were going to be burning all of the aggregates. So we did some aerial surveys and mapped the burnt areas both within the coops, in the aggregates, and around them. And we did find that there were greater burn impacts in the aggregated retention coops. So we ended up burning about 2.6 hectares per coop, as opposed to 1 hectare for a clearfell, burn, and sow coop. But most of that difference is actually due to the aggregates being burnt. So if we look at all of the coops across 4 years, and how much of the aggregate area we might have burnt. We only burnt about 11% of that area. Some other things that we found in the course of the burn mapping were that island aggregates were at greater risk of burning than edges because of their greater exposure, and that smaller islands were more likely to be burnt than larger islands. And that's what's shown on this graph here, where we have percentage burnt on the x-axis and the island aggregate size class on the y-axis. So the size class is increasing as we move across there, and you can see that the proportion of the aggregates that tend to be burnt is decreasing as size increases. So in a half-hectare aggregate, we're likely to have at least 40% of that area burnt, whereas if we move to an aggregate that's about 2 hectares in size, we might only burn about 10% of it. And I should just mention that some burning is actually okay. We're not trying to exclude fire altogether from these aggregates or from these coops, because fire is a natural part of the wet eucalypt forest ecosystem, and some burning will probably actually provide some habitat for pyrophilic species and help to better mimic the natural processes in these forests. But we do try and keep it to a minimum. So in order to get better burns, we've also had some changes in our coop designs because of the difficulty of burning some of these really complicated coops, and because of the issue with burning island aggregates being at greater risk than edges. We've made some changes to our burning our coop designs and started using fewer and larger aggregates and moving towards the use of more edge aggregates rather than the islands out in the middle. And this has made some of these coops easier to burn and safer to harvest. So I just want to talk a bit about seedbed now. And we looked at seedbed in both the aggregated retention and the clearfell burn and sow coops. And when we go and do a seedbed survey, we essentially do plots right across the coop on a grid. And at each plot we decide what the seedbed is, and we have 6 different classes of seedbed that are shown on this graph. The first 3 are unburnt seedbeds with increasing levels of disturbance or compaction. So we have unburnt, then disturbed, then compacted, and then the last 3 seedbed classes shown here are all burnt with increasing intensity, so lightly burnt, moderately burnt, and then ash bed. And this is just showing the proportion of the plots across the coop that fell into each of those seedbed classes. And the main thing to note from this graph is that really there's very little difference between aggregated retention and clearfell burn and sow, which wasn't what we expected. We thought we would have gotten more burnt seedbed in the clearfells. It shows that the slow burning really is working to achieve good seedbed in those coops. So what does this mean for the regeneration? We know that regeneration is pretty closely tied to seedbed. So we also looked and did regeneration surveys. And we've got 2 measures of regeneration success here. One is stocked plots and the other is density. So again, when we do a regeneration survey, we go and put in a small plot, and we look at whether or not that plot contains a seedling. If it does, it's called stocked. And what this first graph is showing is the proportion of stocked plots on each of these coops. And you can see that there's very little difference between the aggregated retention, the blue bars, and the clearfell burn and sow in terms of stocking, and that's both at age 1 and age 3. And the second graph shows the density, or number of seedlings per hectare, which is just another measure of regeneration success. And similarly, there's a bit more of a difference between the ARN and the CBS, but it's not significant. And it's the same, again, at age 1 and age 3. So overall, there was no difference in stocking, density, or height of regeneration between the 2 silvicultural systems. So again, that was a bit of an unexpected result, but encouraging. So what we did find is if we looked at regeneration in terms of those different seedbed classes, and this is showing seedling height across the different seedbed classes, that seedling height was greatest on ash bed, or the really intensely burnt seedbed, that's over on the side, and it decreased on the compacted seedbeds. And if we look at the same thing with density, we can see the seedling densities are highest, again, on the ash beds, so the most intensely burnt seed beds, and lowest in the compacted sites. And that's just confirming what some of Mark Nealon's research at WARA has shown, but over a broader range of different coops, that seedbed really is a pretty key. Seedbed is really key to regenerating these aggregated retention coops. So just to summarize, we've talked a bit about wet eucalypt fire ecology and how fire is an integral part of wet eucalypt forests, both the natural forest ecosystem and also in our forest management. I've talked about variable retention and how this new type of harvesting is making burning a bit more challenging and causing some difficulties in terms of sometimes scheduling these burns. But we've also found that the slow burning methods that we've developed actually do help and have allowed us to burn these coops quite successfully and create good levels of seedbed, and that this in turn has led to really good regeneration. So we can regenerate the aggregated retention coops, but getting that good seedbed is really the key. Thank you very much.